Hello friends. So in this video we are having gate problem which is on finite slope. The problem is like this. For a finite slope, find the factor of safety and data is given to you. Here the saturated unit weight is given to you as 22.67 kilonewton per cubic meter and area under the slip circle is also given. The properties of the ground C cohesion parameter is given to you as 20 kilopascal, and because it is fully saturated and cohesive in nature, you can find out the factor of safety of the finite slope for purely cohesive soil by phi u equal to 0 analysis. And the tension crack which is getting developed in the slope and filled with water up to 2.5 meter below the surface. The radius of the slip circle is given. The central angle delta is also given, and the value of x bar, that is from the center of rotation up to the weight, the distance is x bar, which is 2.5 meter. So the figure is like this. The slope looks like this. This is the top surface. This is the slope. And this slope has got center of rotation. Somewhere here, this is the center of rotation, O, and this side the radius. This angle is called angle delta, central angle, which is 80 degree, and the finite slope, the slip circle is shown here in the figure, and the weight is acting at the CG, and this distance is x bar. There is the slip circle will meet here. So this is the slip circle, and the weight can be shown. This is the weight. So x bar equal to 2.5 meter. And here up to 2.5 meter, it is filled with water. There is a tension crack because it is purely cohesive soil. cohesive. Therefore, you can use phi u equal to 0 analysis to find out the factor of safety. Now, if you read out this problem, the tension crack is filled with water up to 2.5 meter. So this distance is 2.5 meter below the surface. Radius of the circle is given to you, and this distance is also given in the problem in the figure. This distance is 7.5 meter. It's a given. Now, if you are analyzing this problem for finding out the factor of safety, the solution will be like this. So you need to find out the factor of safety will be resisting moment over overturning moment. Now the resisting moment will come into picture because of the cohesion that is coming into picture. So the when and the weight will induce a moment about the center of rotation O, and that will lead to overturning moment. And if you calculate the lateral thrust due to this field of water also will be gamma W into ZW. So the total thrust due to water which is getting filled into this the crack PW, the thrust due to water in the tension crack is therefore given as half gamma W into ZW whole square. So this you can calculate it. 0.5, gamma W 9.81, and ZW is already given to you as 2.5 meter. So 2.5 whole square. So you can calculate what is the lateral thrust that is going to, this additional force will contribute to overturning moment. About the point O, it is trying to overturn the slope. So we can calculate, this is 0.5 into 9.81 into 2.5 square, 30.65. So this is going to be kilonewton per meter. So PW is known to you, 30.65. Okay. Now, this will be acting, that you can find it out, at 1/3 from here. So it will be acting at 2/3 from here. So 2/3 from here of 2.5 meter. So it is going to be 5 by 3. .66 meter. So the point of application from here is known to you, and this is going to be 7.5. So, and this is going to be 14 meter, r equal to 14 meter. So 14 minus 7.5, you will be getting the distance from the center of rotation up to here. So r equal to 14 minus this 7.5 will give you this distance plus 2/3 of this, you will be getting 1.66. So 15.66 minus 7.5, that is 8.16. So the force is acting at 8.16 meter from O, center of rotation. This is the point O. So the overturning moment due to PW will be PW, which is 30.65 kilonewton per meter, multiplied by the distance, perpendicular distance from O, will be 8.60. Okay. And due to the weight, you can calculate the weight. So the weight here, weight under this slip circle, the complete weight of this is given as area multiplied by perpendicular to the board 1 meter per unit meter multiplied by the saturated unit weight gamma sat, that is 22.67 kilonewton. So weight is also known to you. Area is given. The area here is given as 150. So it is 150 into 22.67. So 150 into 22.67 is the weight. So this gives you 3400 0.5 kilonewton. This is the weight, and this weight is acting from the center of rotation at a distance x bar, which is given as 2.5 meter. Therefore, I can find out the factor of safety now very easily. So what is the value of MR? The resisting moment is due to this force of cohesion. When it tries to slip down, fail, along the slip circle, the cohesive force is going to resist it. So this is the for cohesion multiplied by length of the arc. This arc length, you can multiply it. That becomes the force multiplied by the radius about the center of rotation. Whatever force is there, the net force C into L arc, that is going to act, multiplied by the radius of this slip circle. Now, what is the value of L arc? The value of L arc can be written as C multiplied by L arc will be R into delta. So it will be R into delta into R. So you can say it is R square. So it becomes C R square into delta. Now delta should be in radians. This must be in radians. So to calculate it in radians, now I know this magnitude of the force, and I also know the distance from here to here. It is 8.16 meter. So this is the force. So this distance is also known to be. So let me calculate now the resisting moment. So resisting moment can be computed now, can be calculated. So I can calculate MR. Is going to be, the resisting moment is going to be, therefore the resisting moment equal to C is given to me as 20 kilopascal. So 20 into R square. R is 14 meter into delta. Delta is 80 degree. So in radians, you will have to convert it. So 180 degree equal to pi radians. Therefore, 80 degree will be pi by 180 into 80 radians. So it should be multiplied by pi divided by 180 to convert it into radians. So C R square delta in radians we have written over here. This is going to be the resisting moment. So if you calculate it, 20 multiplied by 14 square into 80 multiplied by pi divided by 180. So the resisting moment is 5473.35 kilonewton meter. Now in the denominator you have got overturning moment. So here the resisting moment I have already calculated as 5473.35. Now I will calculate the overturning moment. The overturning moment is due to the weight, and weight I have already calculated because the area under the slip circle is given to me. The complete area is given to me. So area into 1 gives you the volume multiplied by the saturated unit weight gives you the weight in kilonewton. So it is going to be 3400.5. So 150 into 22.67 Right, 3400.5. So I know the weight. So what will be the overturning moment? W into x bar. W into x bar. So this will try to overturn the whole system. Now there is an additional force, PW. So this will also contribute to the overturning moment about O. So PW, in the tension crack, there is a water, and that force is 30.65 kilonewton multiplied by this distance is 8.16 meter. So into 8.16. So the overturning moment therefore becomes 3400.5 into 2.5 meter plus PW is 30.65 multiplied by 8.16. So if you calculate this, let us calculate. So multiplied by 2.5. $65 into 8.16. This is going to give you 8751. So 8751.35. So I have got the overturning moment 8751.35. So I will calculate now. 5473.35. 0.625. Therefore, the factor of safety comes out to be overturning moment is greater than resisting moment. See here. So naturally, the factor of safety is coming out to be. So here, the factor of safety when you calculate it is 0.625. So it is not safe, not stable. So when you check the stability of this finite slope, you find that the resisting moment is less than overturning moment. Weight is this denominator is more. Naturally, to find out the factor of safety of this finite slope, which is pure clay, it is in purely saturated condition. You can see my previous video on a stability of slopes. So many problems we have already solved in this channel. So you can see those problems. So it was a simple problem with no cracks and all those things. And phi u equal to 0 analysis, I have already explained in my previous videos initially. So those things, if you see, this is the answer. So this is the final answer. So the factor of safety we have been able to calculate. So the answer is 0.625. I hope you have understood in totality, and I have tried my level best to explain this. I will go to the next problem now. The next problem is like this. So, GATE 2025 problems are quite interesting. Friends, the next problem is on consolidation. The problem is like this. The problem says that given data are time required for 50% consolidation T50 equal to 2 years. This is given to you. So 2 years is the time, and the coefficient of volume compressibility MV is also given as 1.51 into 10 raised to minus 3 meters squared per kilonewton. So this is also given to you. The unit weight of water is given to you as 9.81 kilonewton per meter cube, and there is going to be double drainage. You have got top layer is going to be sand. So this is sand layer, and then you have got clay layer of 6 meter depth, followed by again sandy layer. So it is a case of double drainage, and you have to find the here with this given data. The question is find the value of coefficient of permeability. So find the coefficient of permeability. Coefficient of permeability means K. So friends, you already know that K solution part, we can see it. How will you find out the value of K? K equal to the coefficient of consolidation multiplied by coefficient of volume compressibility multiplied by unit weight of water. Now, how will you find out the coefficient of consolidation? CV. It is going to be time factor TV for 50% consolidation into drainage path dA square divided by T50. Now, how will you find out this time factor for 50% consolidation? TV time factor for 50% consolidation, because it is less than 60%, it will be pi by 4. For double drainage, U by 100 whole square. Now U is 50. So 50 by 100. So it becomes 0.5. So it becomes 0.197. So time factor is 0.5 square into pi 4. Approximately 0.197. So the 1963 to be exact. So we are getting the value here of time factor. Now, what about the drainage path? D is the drainage path. Because it is a case of double drainage, pore water pressure can dissipate on the top as well as at the bottom because you have got sandy layer up and down. So in my previous videos also I have explained all those things. So it will be the height of clay layer divided by 2 for double drainage. And height of clay layer is 6 meter by 2, it becomes 3 meter. So you know the drainage path now. And T50 is already given in this problem as 2 years. Therefore, CV equal to 0.197 multiplied by drainage path is going to be TV50 ds square divided by T50, and T50 is 2 years. So this will be meter square per year. So let me calculate this. 0.197 0.8865. The CV value is 0.8865 meter square per year. CV is known to me, MV is given, gamma W is given, therefore calculate the value of K. So simple. So if I want to calculate now the value of K, I will have to substitute everything in 1. So substituting, therefore, the coefficient of permeability will be 0.8865 multiplied by 1.51 into 10 raised to minus 3 into 9.81. So multiplied by 1.51 minus 3 multiplied by 9.81 gamma W value. So this is going to be K value is 0.01313 meter per year. This year can be converted into months, it can be converted into days, it can be converted into hours, it can be converted into other minutes or seconds. So whatever you convert it, this you can get the value. So in a year, this will the coefficient of permeability is going to be this meter per year. So this is the answer of the coefficient of permeability. Find the coefficient of permeability. So this we have found out. So K value is going to be this. So this is the answer. This problem was asked in GATE examination, and you see in just 2 steps one can solve this problem. The next problem, which was in the afternoon paper of GATE 2025, recently concluded. You all must have seen the question paper. The next question is, find n gamma. It's a bearing capacity problem based on plate load test. Find n gamma for a circular plate. Resting over the surface, resting over the sandy bed. The gamma value is given as 16.66 kilonewton per cubic meter for the sandy bed. And the diameter of the plate circular plate is given as 1 meter, and the ultimate bearing capacity is given so much of kilopascal. So you will have to find out the solution of this problem. Friends, again a simple problem that all of you must be knowing. Find out the solution of this problem. How will you attempt? You say you have a circular plate. This is the circular plate. This is resting over the surface. So this is the ground surface. And this plate diameter is given to you. Right? And the ultimate bearing capacity Qu is given to you as 1500 kilonewton per meter square. And the unit weight is also given to you kilonewton per cubic meter. So with this information, you will have to find out the bearing capacity factor n gamma. So the solution part will be, we know the ultimate bearing capacity Qu for a surface footing or a surface plate resting over the sandy bed will be, C will be 0. There is no surcharge, therefore second term will be also 0. The third term will be 0.3 gamma d n gamma. So 0.3, 16.66 gamma d n gamma, or 1500 equal to this. Therefore, n gamma is 1500 divided by 0.3 into 16.66. So let's calculate this, and it's a factor. So it's a dimensionless quantity, bearing capacity factor. So 1500 300.12. So n gamma equal to 300.12. 1, 2. So, this is the answer of this problem. Friends, we have solved the afternoon paper of GATE 2025. All the problems we have solved it. So, having solved this particular problem, I hope that GATE 25 problems you can attempt very nicely without any problem. Thank you very much.